Hello guys, welcome back to our channel. Today we are going to learn about quadratic inequality. Let's look at what are we going to learn today. First, we are going to look at some basic inequality rules. Then, we are going to learn how to solve quadratic inequalities. And then, we are going to revise on conditions for different types of roots. And finally, relations between a straight line and a curve. Before we start, let's look at some basic inequality rules. Let's look at the first one, reversal property. If A is lesser than B, then B is greater than A. Let's look at the second property, the transitive property. If A is lesser than B and B is lesser than C, then A is lesser than C. Let's look at the third property, multiplication or division property. Multiplication or division of a negative number will flip the inequality sign. Let's look at this example. If 5 is greater than negative 3, then negative 5 is lesser than 3. Notice the inequality sign is flipped when we multiply or divide a negative number. There are two methods of solving quadratic inequalities. First, by using graphical method. Second, by using number line method. Now let's look at the first example. Solve the following quadratic inequality. X squared minus 11x plus 24 is greater than 0. First, you need to factorize this quadratic inequality. You will get x minus 3 multiply x minus 8 is greater than 0. Let's look at how we solve this question using graphical method. First, you need to identify the roots of this quadratic function, which are 3 and 8. Then, you need to sketch the graph of x squared minus 11x plus 24, which is a U-shaped graph with a minimum point. Remember, you don't have to sketch a complete graph. You just need to sketch a few important things, which are the shape of this graph, the x-axis, and remember to write down the roots as shown in this diagram. Then you need to look at the question. In this question, the inequality sign is greater than 0. So you need to shade the area of this graph which is greater than 0. In other words, anything above the x-axis. As you can see here, anything lesser than 3 and anything greater than 8 will be the answer. So your final answer will be x lesser than 3 or x greater than 8. Now let's look at how we solve this question using number line method. After we have factorized this quadratic inequality, you need to split this quadratic inequality into two, which are x minus 3 greater than 0 and x minus 8 greater than 0, and you get x greater than 3 and x greater than 8. Remember, this is not the final answer. You need to draw a number line which consists of the number 3 and 8, and you need to divide the number line into 3 different partitions as shown in this diagram. Then you need to draw two arrows, which are x greater than 3 and x greater than 8. Remember, the arrow always carry the positive sign. Meanwhile, the region without an arrow will be represented by the negative sign. Now you need to label each partition with an overall sign. Negative and negative will give rise to a positive sign. Negative and positive will give rise to a negative sign. Positive and positive will give rise to a positive sign. Now you need to look at the question. The inequality sign for this question is greater than 0. So your answer will be anything in the positive region. So your final answer will be x lesser than 3 or x greater than 8. For this teaching purpose, I will show to you both methods. But personally, I will recommend you to use graphical method when solving quadratic inequalities. But you still need to learn the number line method, especially when you deal with polynomial inequalities. Let's look at the second example. Negative x squared minus 2x plus 15 is greater than 0. One of the methods we can use to solve this question is by multiplying the inequality with a negative sign, and you get x squared plus 2x minus 15 is lesser than 0. Remember to flip the inequality sign after you have multiplied it with a negative sign. Then factorize it and you get x plus 5 multiplied x minus 3 is lesser than 0. Let's look at the graphical method. The roots for this quadratic function is negative 5 and 3. Now you need to sketch the graph for this function x squared plus 2x minus 15. This is a U-shaped graph with the roots negative 5 and 3. Look at the question. The inequality sign is lesser than 0. Now, you need to shade the area below the x-axis, which is anything between negative 5 and 3. So the answer will be x greater than negative 5 but lesser than 3. Now I will teach you how to use the number line method. After you have factorized the quadratic inequality, split them into two. X plus 5 is lesser than 0 and x minus 3 is lesser than 0. Then you get x is lesser than negative 5 and x is lesser than 3. After that, draw the number line which consists of roots negative 5 and 3. Then you need to draw two arrows which are x lesser than negative 5 and x lesser than 3. Remember, the arrows will carry the positive sign. Meanwhile, the region without an arrow will carry the negative sign. Now let's look at each partition. Positive and positive will give rise to a positive sign. Positive and negative will give rise to a negative sign. Negative and negative will give rise to a positive sign. Look at the question. The inequality sign is lesser than 0. Therefore, the answer will be in the region of negative. And your final answer should be x greater than negative 5 and x lesser than 3. Now I will show you the second way of doing this question. Negative x squared minus 2x plus 15 is greater than 0. Factorize this inequality and you get negative x plus 3 multiply x plus 5 is greater than 0. Let's look at the graphical method. The roots for this quadratic function is negative 5 and 3. Look at the question. You need to sketch the graph of negative x squared minus 2x plus 15. So this is an inverted U-shaped graph with the roots negative 5 and 3. Look at the question. The inequality sign is greater than 0. So you need to shade the area above the x-axis, which is anything between negative 5 and 3. So your answer will be x is greater than negative 5 but lesser than 3. Let's look at the number line method. After you have factorized this inequality, you need to split them into two. X plus 5 is greater than 0 and you get x is greater than negative 5. Meanwhile, negative x plus 3 is greater than 0 and you get negative x is greater than negative 3. Multiply with a negative sign and you get x is lesser than 3. Now you need to draw the number line with two arrows, which are x is greater than negative 5 and x is lesser than 3. Remember, the region on the arrow will be represented by a positive sign. Meanwhile, the region with no arrows will be represented with a negative sign. Let's look at each partition. Positive negative will give rise to a negative sign. Positive positive will give rise to a positive sign. Negative positive will give rise to a negative sign. Look at the question. The inequality sign is greater than 0. So your answer will be in the positive region. So your final answer will be x is greater than negative 5 but lesser than 3. Use the same method and try this question. Let's look at this example. Given that f of x equals to negative x squared plus 4x plus 4, find the range of value of x that satisfy f of x is greater than negative 1 but lesser than 7. To solve these two quadratic inequality, first you need to split them into two. Negative 1 is lesser than f of x and f of x is lesser than 7. Let's look at the first one. Negative 1 is lesser than negative x squared plus 4x plus 4. Rearrange the inequality and you get x squared minus 4x minus 5 is lesser than 0. Factorize it and you get x plus 1 multiply x minus 5 is lesser than 0. To solve this inequality, you need to sketch a U-shaped graph with the roots negative 1 and 5. Look at the inequality sign, which is lesser than 0. So shade the region below the x-axis and you get the answer x is greater than negative 1 but lesser than 5. Look at the second one. Negative x squared plus 4x plus 4 is lesser than 7. Rearrange this inequality and you get negative x squared plus 4x minus 3 is lesser than 0. Multiply with a negative sign and you get x squared minus 4x plus 3 is greater than 0. Factorize it. You get x minus 1 multiply x minus 3 is greater than 0. To solve this inequality, you need to sketch a U-shaped graph with the roots 1 and 3. Look at the inequality sign, which is greater than 0. Shade the region above the x-axis. So you get the answer x is lesser than 1 or x is greater than 3. Remember, this is not the final answer. To get the final answer for these two quadratic inequalities, you need to draw the number line which comprises of 4 different roots, which are negative 1, 1, 3 and 5. Now you need to draw two sets of arrows. First between negative 1 and 5, which will represent x is greater than negative 1 but lesser than 5. Second, you need to draw x is lesser than 1 or x is greater than 3. Look at the yellow region where the two arrows overlying each other. This will be the final answer. X is greater than negative 1 but lesser than 1 or x is greater than 3 but lesser than 5. Look at the next example. Find the range of x for modulus x squared plus 5x minus 10 is lesser than 4. To answer the question involving modulus inequality, you need to memorize a few sets of formula. Generally, if modulus x is lesser than a, then x is greater than negative a but lesser than a. If modulus x is greater than a, then x is lesser than negative a or x is greater than a. Look at this question. Modulus x squared plus 5x minus 10 is lesser than 4. If you look closely at the formula given, you will get x squared plus 5x minus 10 is greater than negative 4 but lesser than 4. Since you have two simultaneous inequalities, you need to split them into two and just follow the same steps as I mentioned to you earlier in the previous question. Let's revise on the chapter condition for different types of roots. If b squared minus 4ac is greater than 0, the equation has two distinct real roots. If b squared minus 4ac equals to 0, the equation has two equal real roots. If b squared minus 4ac is lesser than 0, the equation has no real roots. And if b squared minus 4ac is greater or equals to 0, the equation has two real roots. Look at this question. The function f of x equals to x squared plus mx plus 4 has two distinct real roots. Find the range of values of m. Since the function has two distinct real roots, therefore b squared minus 4ac is greater than 0. Substitute all the values into the inequality and you get m squared minus 16 is greater than 0. Now you have a shortcut to write down these answers. Look at this table. Generally, if x squared is lesser than a, therefore x is greater than negative square root of a, but lesser than square root of a. If x squared is greater than a, therefore x is lesser than negative square root of a, or x is greater than square root of a. Since m squared is greater than 16, therefore m is lesser than negative 4, or m is greater than 4. If you can memorize this formula, you can save time by writing these answers without the need of using graphical method or number line method. Look at this example. Find the range of values of p such that 2x squared minus 4x plus p is always positive for all real values of x. Look at this function 2x squared minus 4x plus p. Since the a value is positive, therefore this will be a U-shaped graph with a minimum point. Since the function is always positive for all real values of x, therefore the graph will always be above the x-axis. In other words, this function has no real roots. Therefore, b squared minus 4ac is lesser than 0. Substitute all the values into the inequality and you get the final answer, p is greater than 2. Look at this example. Show that the equation in the bracket 2 minus 3k x squared plus x plus 3 over 4k equals to 0 has real roots for all real values of x. Since the equation has real roots, therefore b squared minus 4ac is greater or equals to 0. Substitute all the values into the inequality and you get in the bracket 3k minus 1 squared is greater or equals to 0. Since squaring of any numbers will always give you 0 or greater than 0, therefore you have proven that this equation has real roots for all real values of x. Let's move on to the next topic, relations between a straight line and a curve. If b squared minus 4ac is greater than 0, the straight line intersects the curve at two distinct points. If b squared minus 4ac equals to 0, the straight line intersects the curve at only one point. In other words, the straight line is tangent to the curve. If b squared minus 4ac is lesser than 0, the straight line does not intersect the curve. It can be also written as the straight line does not meet the curve. Look at the first example. Find the value of p for which the x-axis is a tangent to the curve y equals to x squared plus in the bracket 2p plus 10x plus p squared plus 5. Since x-axis is y equals to 0, first you need to equate the curve with the straight line. X squared plus in the bracket 2p plus 10x plus p squared plus 5 equals to 0. Since the straight line is the tangent to the curve, Therefore, b squared minus 4ac equals to 0. Substitute all the corresponding values and you get the answer p equals to -2. Look at the second example. The line y equals to 12 minus 2x is a tangent to two curves. Each curve has an equation of the form y equals to k plus 6 plus kx minus x squared, where k is a constant. Find the values of k. First, you need to equate the straight line with the curve, and you get 12 minus 2x equals to k plus 6 plus kx minus x squared. Rearrange this equation, you get x squared minus in the bracket 2 plus kx plus 6 minus k equals to 0. Since the straight line is a tangent to the curve, therefore b squared minus 4ac equals to 0. Substitute all the corresponding values and you get the final answer k equals to -10 or k equals to 2. Use the same method and try this question. Look at this question. Sketch the graph of f of x equals to modulus x minus 2 plus 1 and g of x equals to x squared plus 3 on the same diagram. Find the x coordinate of the points of intersection of the graph. Then, find the range of value of x so that f of x is greater than g of x. First, you need to sketch the graph g of x equals to x squared plus 3. This is a U-shaped graph with a minimum point 0, 3. Then you need to sketch the graph f of x equals to modulus x minus 2 plus 1. For those who still do not know how to sketch a modulus graph, please go back to the previous video of absolute value function and learn how to sketch a modulus graph. F of x is a V-shaped graph with a vertex 2, 1 and a y-intercept of 0, 3. If you look closely, these two graphs has 2 points of intersection, which located at the negative gradient of the modulus graph. The positive gradient of the modulus graph has no point of intersection with the quadratic graph g of x. So we can expect if we let f of x equals to g of x, there will be no solution of the positive gradient of the modulus graph. To find the point of intersection, we let f of x equals to g of x, modulus x minus 2 plus 1 equals to x squared plus 3. Rearrange this equation and you get modulus x minus 2 equals to x squared plus 2. There are two possibilities. First, x minus 2 equals to x squared plus 2. Rearrange it and you get x squared minus x plus 4 equals to 0. There will be no solution for this quadratic equation. As I mentioned to you earlier, you can confirm it by using b squared minus 4ac and you should get the answer lesser than 0. The second possibility, x minus 2 equals to negative in the bracket x squared plus 2. Rearrange and expand this equation and finally you get x multiply x plus 1 equals to 0 and you should get the final answer x equals to 0 or -1. Look at the third part of the question. Find the range of values of x so that f of x is greater than g of x. If you look closely at the graph, there's only one region where f of x is greater than g of x, which is between the point -1, 4 and 0, 3. So your answer will be x greater than -1 but lesser than 0. Look at the next question. A straight line y equals to 7x plus m meets the curve y equals to modulus -2x squared plus 3x plus 5 at 3 different points. Find the value of m. This question is a little tricky and it requires a deep understanding of these two graphs. Look at this function. Y equals to modulus negative 2x squared plus 3x plus 5. This is how the graph looks like. Look at this straight line. Y equals to 7x plus m. For this straight line to meet the curve at 3 different points, there is only one possibility. Look at this diagram. For this to happen, the straight line must be a tangent to this quadratic equation y equals to negative 2x squared plus 3x plus 5. To solve this question, you must let 7x plus m equals to negative 2x squared plus 3x plus 5. Rearrange this equation and you get this form. Since the straight line is tangent to the curve, therefore b squared minus 4ac equals to 0. Substitute all the corresponding values and you get the final answer m equals to 7. That's all for today. Thank you for watching. I'll see you in the next video. Bye.